Okay, Year 7. Welcome to your second introduction lesson to algebra. Yesterday, we talked about things like coefficients, pronumerals, expressions. Okay, today we're going to look at one new term and start doing some examples. Okay, you do not have to write this as a new heading in your book. Rather, you can just start writing from the next slide onwards. Next in your rule book, underneath yesterday's definitions and yesterday's writing, you need to write the final definition, which is that of a term. Now, a term can either consist of numbers or pronumerals, or both. For example, 5 is a term, X is a term, 9A is a term, ABC is a term, and 43XYZ. Now you'll notice that they're very different types of terms, okay? X is just a pronumeral, just by itself. Now it doesn't appear to have a coefficient or a number in front of it. You might remember from last lesson that if I have a pronumeral that doesn't have a coefficient, it means the coefficient is 1, or there's one instance of X, okay? This one here, there's one instance of A, B, C, okay? This term here, 5, is a constant. So it means that there's no pronumeral, there's nothing that I don't know about it, it is simply the number 5. 9A, my pronumeral is A and it has a constant of 9. XYZ has a constant of 43, so 43 is the number in front of it. Okay, so a term can either consist of numbers and pronumerals, or just a number, or just a pronumeral. So, here's an example of a question that you might be asked to answer in order to prove that you've understood the thing so far. It's wanting to know, it asks, list the individual terms in the expression. Now, there's a term that says 3A, a term that says B, and a term that says 13C. Now, how did I know that they were all terms? Well, there's a name I give this whole thing, and we learnt about it yesterday. It was called an expression. The whole thing is called an expression. These individual guys, these are called terms, okay? And within a term, you can have pronumerals, and you can also have coefficients. So 3 is the coefficient of A, 13 is the coefficient of C. Now B doesn't have a coefficient in front of it, so I know that there's only one instance of that B. Okay, so it's asking me here not to do anything but list the terms. So I know one term is 3A, and then it's separated to B. B is the second term. And then the third term is 13C. In an expression, terms are separated by operators. Addition, subtraction, or division. They're the things that separate my terms in an expression. Okay, the same question. This time it's asked me to state the coefficient of each pronumeral. So this is how I'd write it. Okay, I've got the first bit here is 3A, that's the first term. It's asking for the coefficient of each pronumeral. The coefficient of A is the number in front of it. How many instances of A do I have? Well, I have 3. The coefficient of C, in this example, I'm jumping to the end here. The coefficient of C is 13. It's just the number in front, guys. Now, it appears I have a problem when I get to B, but I'm hoping this might be something you guys remember. If a pronumeral doesn't have a coefficient in front of it, or it doesn't tell me exactly how many instances of it there is, it means the coefficient is 1. Okay, so B didn't have a coefficient in front of it, which means it's not equal to 1, but there's only one instance of B. Ooh, okay, so now this last question that you might be asked to do in order to prove that you understand how to do the things that you've learned is you might be asked to write your own expressions. So it says, write an expression for each of the following. 5 more than K. Okay, 5 more than K. So I start with K, which represents something I don't know, and then I add 5 to it. When I'm talking more than, the operation I'm looking for is addition. That one more time. When I'm talking about more than, the operation I'm looking for is addition. More than, addition. So I'm hoping you'll get this one. Less than, okay, less than, if more than is addition, less than must be the opposite. What's the opposite of addition? What's the opposite? Oh, subtraction. And it's 3 less than m. Remember, look how that reads. That's not m less than 3. That's 3 less than m. So I start off with m and I'm less 3. Less than is subtraction. The sum of A and B. This word sum, what does sum mean? When I sum something, sum means addition. So I'm going to have A plus B. Sum means addition. What I'd be doing, if you don't know any of these terms, like more than or less than, if you didn't get that, I'd be writing a little note off the side for myself, going addition, sum, addition, again. Okay? Less than, subtraction. And obviously not writing your notes as messy as I am, but writing yourself a note somewhere. Double the value of X. Okay, what operation does W mean? Double the value of X. When I double something, I multiply it, don't I? But by how many? When I double something, how many do I multiply it by? Oh, 2. So 2 times X. I really hope a few of you are sitting there at the moment going, oh, that's not right, that's not right, that's not right. Because in your notes yesterday, you wrote that when you have multiplication in algebra, we no longer write 2 times X, okay? We simply write 2X, okay? E, the one for E, product, okay? That word product means multiplication, okay? Multiplication, that's really important. So when I multiply the product of C and D, that's C multiplied by D. Again, if you go to write C multiplied by D, I'm hoping some people are sitting there going, no, miss, no. I don't write the multiplication sign anymore. I write it like this, C, D. That's how I write multiplication. This very last one, guys, these are some of the super tricky examples. What I would like you to do, rather than writing these in your rule book, I would like you to open up your grid book and attempt to do A, B, C, D. Once you've done those, I need you to come and see me and see how you went, okay? If you start to struggle with those, this is okay. It's not the end of the world, okay? But I'd like you to try these ones, A, B, C, and D, in your grid book, okay? And that's it, guys. That's your introduction to algebra part 2.